Hello, hi, a very happy good evening. So this is Krishna and we've been talking about the story of life on earth, and that's biology. So welcome to my new series, that is the new beginning. So I hope you're all really doing good, and thank you so much for joining my session today. So hi Supriya, hi Bhavya. Yes, I'm doing good. Thank you so much for joining my session. So please don't forget to like, share and subscribe. So Bhavya, I guess you were not there yesterday, so I hope you have watched the recorded lecture at least. Okay, so please do share the link of the channel with your friends, your seniors, your siblings, anyone who is in need, so that they will benefit from this free platform. So alright, so we are done with 2 chapters so quickly in human physiology. So it's so surprising like how quickly time flies, right? So I just feel like just now I introduced this new series, that is the new beginning, and so soon I am done with almost 2 chapters, so digestion and absorption, and I'm done with breathing and exchange of gas, and today we are into the 3rd chapter. So meanwhile your physics and chemistry lectures are coming soon, don't worry. So I am like, oh my god, time really flies fast, and of course it does. Ma'am, PDF of yesterday's class has not been uploaded yet on CP app. Okay, I will talk to them. Yes, you have watched. Okay, I'll ask them to upload it. I'll give them a reminder. Fine. So thank you once again for joining my lecture, and please don't please don't be very disappointed about your physics and chemistry lecture. It is coming, and please do like, share and subscribe. Fine, so without any further delay, so let's make the class very short and crisp. So today we are moving into the next chapter, that is body fluids and circulation. So we are going to talk about blood and its components. So when we talk about the circulatory system, actually who discovered the circulatory system? So it was William Harvey who discovered the circulatory system. So initially we thought there was nothing like the circulatory system, so we did not have any clue about what is heart, what is blood vessel, what is blood, etc. So when you talk about medicine or physiology, it dates back to Greek, right? So Greek people were the well knowledgeable people, and like your Hippocrates and aristocrats. So they were the people who were pioneers in this field, right? So according to the Greek people, it was said that the body is balanced by 4 fluids. So you had the water, you had blood, yellow bile and the normal bile, right? So they said that it was your entire body and your mind worked on these 4 fluids, but later the Britain people came, the English people came, and there was a beautiful scientist, so he was a very knowledgeable person, he was called as William Harvey, and he discovered the circulatory system, and from then on we understood, okay, so there are blood vessels, there are veins, there are arteries, and this is the heart, and this is how the circulation happens, and hence the treatment came forward for your allopathic medicine. Well, so when we talk about circulatory system, so it is understood, so blood is a common transport, right? It is like a public transport. So everything that has to move inside your body moves through the blood. So be it drug, be it injection, be it hormones, be it nutrients, everything moves through your blood, right? So blood is the most common transport that all of us look forward to. Like if you want to travel overseas, if you want to cross all the 7 seas, so we obviously look for a flight, right? So we look for a public transport, so we don't prefer to take a private one. So much in the same way, so blood is the common transport. So before that, what is the circulatory system? So whenever I say the term system, the system means it has 2 or 3 members. A system is not an isolation, so it is a combination of 2 to 3 members. Your circulatory system, the components of your circulatory system includes your human heart, which is 4-chambered. Then you have the blood, the most important part, and we are going to talk about the blood vessels. So these 3 makes up the circulatory system. So today we are beginning by talking about blood and its component. So this is huge, okay? Actually blood, that is the study of blood, is known as hematology. So that itself is a huge volume, but I'm going to condense it, I'm going to crisp it so that I talk only for 25 minutes and we'll be done with blood and its components. Fine? Okay, so without any further delay, let's move forward talking about blood and its components. Fine. So why do we need a circulatory system? Yes, we have a circulatory system, but what is the need? So for everything, yes, I agree, your body was architectured by God, and we do not know the function of so many things today. Yes, I agree, even today we do not know the entire trafficking of the normal cell. So the functions that the cell does is really mind-blowing, and we do not know how much it does at a particular time, right? Okay, though everything has been designed, architectured, planned by God, but what is the need of this? Behind everything you find a purpose, you find a need, right? So maybe now you do not understand why you're reading physics, why you're reading maths. But yeah, even I was a life science student, but I really had no clue why I'm studying maths. But yes, even in my masters I did maths, because and then I understood there is a relation between maths and genetics, and that is why George Mendel incorporated it, right? So everything you'll understand it later. So similarly, why and for what purpose your circulatory system was designed. So what is the function of circulatory system in the body? Well, so your body has cells. So cells make up tissues, tissues make up organs, and organs make up the organ system, right? So who supplies the essential nutrients to the cell? Who takes up the waste from the cell? So if suppose, let's say you have your house, right? So you go to the market, get the things that you need, and you keep it. Your mama and papa, they go to the market, they get all the things they need to run the family for this month, and they stock it in the house. And every day the waste is collected and it is thrown out, right? So much in the same way, we are supplying the cells with a lot of energy, and at the same time we collect the garbage from the cell. So who supplies it and who takes it out? That is the blood circulation. So in a nutshell, that is why we need circulation, and blood forms a major part of the circulation. So now we are going to talk about the components of the blood. So the blood is pretty complicated. It's not as simple as we think. So it itself is humongous, so that's circulatory part. So we are going to talk about one small peck about blood, so which covers your NCERT, and a bit extra so that you can read a blood test report. So I hope all of you have done a blood test report before. Yes? Okay, so apart from doing a blood test to find out which blood group you belong to, so we have also done blood tests for various other diagnostic tests, right? So if you are weak, so doctor usually asks you to go for a platelet test so to see if you're anemic or not, right? So if you have less hemoglobin, so the doctor asks you to go for a blood test to see if you're anemic or not. So for various reasons we go for a blood test, and there are so many terms in a blood test, right? So we'll look into the terms and we'll see if you can understand. So that is also one way or one step ahead to become a doctor. So you should understand the medical terms, you should know how to comprehend a medical file. So everything will be in medical terms, so everything will not be in some simple languages, right? So if I am talking a language of wax, then I should know which is the plus sign, which is the negative sign. So when I am comprehending or when I am communicating on a medical language, so I need to know certain medical terms, right? That is all we're going to discuss for today. So let's move forward. So why do we need a circulatory system? I have explained. So why do we need? So for all those, yes, Aniris, hello, a very happy good evening. So thank you so much for joining my lecture today. So please do like, share and subscribe. Fine. So we have cells. So group of cells make up tissues. So these cells produce ATP, for which we need to supply the cells with nutrients. So what supplies the cells with nutrients and what takes the waste material out of the cell is your circulation, and that is the main reason we need a circulatory system. Fine. So well, we are going to talk about blood today, and blood is classified into two main regions. The first part of the blood is known as formed elements. They are basically the cells, the solid cells in the blood. So a blood has formed elements. So this has your RBC, your WBC and the platelets. So we know RBCs are erythrocytes. So WBCs are leucocytes. And platelets are thrombocytes. Right? So these are the formed elements that is present in your blood. So the other part of the blood is plasma. So plasma is the liquid portion of the blood. So blood is not solid, so blood is fluid, right? It is a viscous fluid. So that viscous fluid portion comes from the plasma region of the blood. So it is also known as the watery portion or the fluid portion of the blood. So first part of the blood is the formed elements, that is nothing but the cells. So this includes RBC, WBC and platelets, and your plasma includes two parts, that is solid and the water portion. So plasma is formed by a major chunk of water, so 91% of your plasma is water. The remaining 9% is made up of solids. What kind of solids it can be? It can be organic and it can be inorganic. So So organic is one formed by the backbone with carbon, and inorganic does not have carbon backbone. So when I say organic, so organic is further divided into two. One is plasma proteins and the other is urea, glucose, etc. So plasma proteins are very important. They constitute 7% of the plasma, and plasma proteins are needed for better functioning. So we are going to talk about the functions of the plasma proteins as well. So talking about the inorganic component includes the cations and the anions. So the cations include your Na+, K+, calcium, magnesium. Everything that has a positive charge is cations. And talking about the anions, this is Cl-, bicarbonate, phosphate and sulfate. So these are the components of the blood. Yes, Shubham sir, hello, very happy good evening and welcome to my lecture. So thank you so much for joining us today. So please don't forget to like, share and subscribe. So once again giving you a summary of this classification. So blood, so the important part of the circulatory system is divided into two major chunks. So one is the formed elements, the other one is the plasma. So plasma is the fluid part and formed elements is made up of solid cells, which includes your RBC, WBC and the platelets. And plasma is the fluid portion, so it has a major chunk of water and solids. The solids are further classified into organic and inorganic. So organic includes my plasma proteins, which make up 7%, and the inorganic includes the cations and anions. So this is the major classification of blood, and these are the components of blood. So we are going to talk about the components of blood today. Yes ma'am, a very happy good evening. So thank you so much for joining our lecture today. Thank you for being with us. So please don't forget to like, share and subscribe. Fine. So I guess this classification is clear. So moving forward, so let's describe blood. So study of blood is known as hematology. So logy is the study. So hematology is the study of blood. Yes, you have a separate paper that is hematology where you study about blood. So the process of blood formation is hemopoiesis or hematopoiesis. So poiesis is a Greek term that means formation, right? So formation or the process of formation of blood is known as hemopoiesis or hematopoiesis. So your blood formation takes place in the bone marrow, right? Okay, so this is our first 2 points. And what is the pH of blood? And that's a question that's often asked. So that is something very basic to test your understanding in biology as well as your prerequisite for medicine, you can say. So the pH of blood is 7.4. It is slightly acidic. So never say your pH of blood is 7. So please try to be so perfect and accurate. So the right pH of blood is 7.4 and it is slightly alkaline. So this is your pH of blood, right? So moving further, so males have 5 to 6 liters of blood, whereas females have only 4 to 5 liters of blood. So this is on an average, but can you tell me why males have more blood and females have average less blood? So when I say males have 5 to 6 liters of blood and females have only 4 to 5 liters, can you tell me why? So can you guess why so? So God has equally created male and female, so both are equally talented. So there is no difference in the brain size. But can you tell me why male has more blood of 5 to 6 liters and females have of only 4 to 5 liters of blood? Yes, can you guess anything? How, why, what it can be? Yes, any guess that would help? So you should keep thinking. So thinking should never stop. That is the reason I don't give straightforward answers in class anytime, because your thinking should not stop, right? Yes, quick. Any guess as to why males have more blood compared to females? Yes. To be clear, it's not because of the menstrual cycle. So any other reason can you think of? Because the first reason that students give me is they say, ma'am, females have menstrual cycle. No, it's not because of menstrual cycle, because in menstrual cycle it is not that the females lose liters of blood. No. So then in that condition, so why is that the males have more blood compared to the females? Yes, can anyone guess and give me the answer? Any try? Yeah. It's logical reason, so it is not any mythological reason, any myth, nothing. It's a logical reason. If you could guess and try. Yes, Bhavya. Yes, Supriya. Any guess? Why males have more blood? Okay, so I'll leave this question in mid-air for you to answer. So I want you guys to ponder over this question and get back to me. So directly giving you the answer would stop your thinking ability. So I leave this question mid-air. So understand, until you come back and ask me why, or you resonate or you argue with me as to this is the reason, so I will not talk about this further. Okay. Yes, so here we move. So this is the pH of the blood, this is the process of formation of blood and study of blood. So in your blood test report, you have one term, what is PCV. So this stands for packed cell volume. So what does packed cell volume mean? So the percent volume, or the total number of blood cells, blood corpuscles in the blood. So the total number of formed elements in your blood. So packed cell volume talks about the total number of WBC, total number of RBC and platelets in your blood. So that is packed cell volume. The next one is hematocrit volume. So hematocrit is the percent or the number of RBC alone. So here I take into account WBC, RBC and platelet, but hematocrit is the number of RBC in blood alone. Fine? Okay. So now talking about the plasma portion of the blood. So plasma is straw colored. Okay. So this plasma portion of the blood has 91% water and the remaining as solids, right? So that solids is divided into inorganic and organic. The organic portion has plasma proteins. So plasma proteins are highly significant because, let's see, what are they? So plasma proteins are fibrinogen, globulins and albumins. So these are the three plasma proteins and they are the major plasma proteins which is highly needed. So it is not possible for us to survive without them. So the plasma proteins include fibrinogen, globulins and albumins, right? So for a better correlation, so when we were talking about digestion, we were talking about trypsinogen, chymotrypsinogen. So whenever it ends in nogen, it is in the inactive form, right? So I am just correlating. So the three plasma proteins are fibrinogen, globulins and albumins. So moving further, so what is the function of each one of them? So that is what we are going to talk about. The first one is albumin. So albumin is produced by the liver and it helps in maintaining the osmotic balance. It helps in maintaining the fluid balance so that the body fluid level does not change. So that is the function of albumin. So we are talking about plasma proteins, so globulins, fibrinogen and your albumins. So first we are talking about albumins. So albumins are produced by the liver and it is used to maintain the osmotic balance or the fluid balance in the body. So the next one is globulins. So globulins are primarily involved in defense mechanism. So you would have heard about the term immunoglobulins, right? Right. So there are three types of globulins that are present in blood. It is secreted and produced by the liver and the lymphoidal organs. So the last one is fibrinogen, that is the largest plasma protein and it helps in blood clotting. So males have more muscular strength, that is why they have more blood. Yes, absolutely right. So when you say males have more muscular strength, so why or how it is correlated with blood? So can you connect it for me, Bhavya? Yes, I appreciate your answer, but can you be more specific as to how the muscle strength is connected to blood? Yes, Pracy Grace, hello, very happy good evening. So I guess you're new to my sessions. Thank you so much for joining my session. So please do like, share and subscribe. Fine. So these are the three plasma proteins to be sure. We are done talking about So we were talking about albumins, then we spoke about globulins, and the third one is fibrinogen. So globulins are primarily involved in defense mechanism. So they are secreted by the liver and the lymphoidal organ, and the third one is fibrinogen. It is the largest plasma protein and they help in blood clotting. So Bhavya says more oxygen demand. Exactly, you're right. So how does blood help in oxygen demand? That is with the help of RBC and hemoglobin. Yes, absolutely right. So that is the reason why males have more blood compared to females. Absolutely right. Okay. So these are the three plasma proteins, and among these three the largest is fibrinogen. So I hope plasma proteins are clear. So number one, the plasma protein we spoke about is albumin, that helps in maintaining the osmotic balance. The second one is globulins. It is secreted by the liver and there are three types, and it is mainly involved in the defense mechanism of your body. And the last one is fibrinogen, and it is involved in the clotting mechanism. How? So we will talk about it when we are talking about platelets. Clear? So I guess plasma proteins are clear. So we move to the next part of the topic today. So the next part is formed elements. So basically we are going to talk about RBC, WBC and platelets. So formed elements include erythrocytes. This is your erythrocytes, that is RBC. They look like chocolates, right? So then you have leukocytes, and finally it is platelets. So today we are going to talk about these three, and that is the end of the lecture. So with this we cover up blood and its components. Fine. So let's talk about erythrocytes. So what do you know about erythrocytes? So Pranav D. Prasad, so what is osmotic balance? So osmotic balance is the fluid balance. So you have to maintain the pH in your body, right? For example, the pH of blood is 7.4. The pH of the stomach is 1.8 to 2. So to maintain the fluids there so that the pH is maintained, that is osmotic balance. So always there should be some amount of water in your body, some amount of mucus in your body. So that is osmotic balance, hence the pH is maintained. So you cannot entirely survive in an alkaline pH where the pH is 12, right? So the body pH has to be maintained, so that is osmotic balance. Okay, Pranav? Okay, fine. So Pranav, so thank you for joining my session and watching it. So please don't forget to like, share and subscribe. So let's talk about erythrocytes first. So erythrocytes are RBCs. So the mammalian RBCs are biconcave, they are circular and they are enucleated. So what do I mean by enucleated? So they do not have a nucleus, right? So why is that RBC does not have a nucleus? Any guess? Biconcave, dish-shaped. Okay, so RBC is nucleated because, so that actually RBC does not have any cellular compartments as well. Hemoglobin is present, right? So RBC is enucleated. It does not have any cellular compartments because it has only hemoglobin. So that when only hemoglobin is present, it can contribute entirely to that function of hemoglobin and carrying oxygen. So yesterday in the process of respiration, so we spoke about how your oxygen is transported by hemoglobin. So that is the main reason it is enucleated, and it is not having any cellular components. So among the three types of cells, that is WBC, RBC and platelets, your RBCs are the most abundant one. Okay, so they are present in more number. So average of 5 million to 5.5 millions of RBCs per millimeter of blood is present. So how much we have? 5 millions to 5.5 millions of RBCs are present per millimeter cube of your blood, right? So that is a huge amount. So that is why it is abundant of all the three types of cells. Okay. So moving further, RBCs are formed in the red bone marrow in the udders. So RBCs have a red colored iron containing pigment that is known as hemoglobin. So how much amount of hemoglobin should be present in 100 ml of blood? That is 12 to 16 grams of hemoglobin. So when this 12 to 16 gram of hemoglobin falls below normal, that is when you have anemia. Oh my God, look who's here after a long time. Hi Antonia B, a very happy good evening. So thank you for joining my lecture today. So how are you doing? Good? Yes, I am good. Thank you so much, Anthony, for joining our lecture today. So thank you so much for joining with us today. So how are you doing? So you are busy these days? So you are preparing yourself for the next step? Yes? So great, and it's good to see you back here on this platform. Okay, so please do share the link of this channel with the juniors, seniors, your friends, your cousins, etc. So please lend us your support. Okay, fine. So in your 100 ml of blood, you should have 12 to 16 grams of hemoglobin. So when this amount reduces, you suffer from anemia, right? So in your blood test report, so normally doctor asks you for a blood test report to check your anemic level, to check the amount of hemoglobin you have per 100 ml of blood. So when it is below, so when you have only 8 grams, when you have 4 grams, that means you're very anemic, right? So you need to increase the production of hemoglobin, for which you need to have iron containing food. You need to have healthy food, not stop eating pizza, etc., right? So that is the main reason doctors prescribe you to go for a blood test. Yes, you're doing good. Okay, that's really great. You shared with students. Yes, thank you so much, Antonia B. Okay. So for all the new ones, so Antonia B has been my YouTube student for the last 1 year. So he has given his exam on 12th of September, but he has been with me for the entire journey of the last year. Yeah, and he's been a very sincere student, so he used to come to all my sessions well before time, and if at all he misses any lecture, so he used to tell me, ma'am, I have watched the recorded lecture. So he was a very sincere student, he was a very hardworking student, so any doubt he would get back to me in Telegram, he would contradict me, he used to give me ways to think about the things in a different way. So I enjoyed teaching Anthony Abbey, so he was one of my YouTube students who stayed with me all the year, and thank you so much. Okay, so Aniket Aryan, so take my name. Okay, hello and welcome to my session. So thank you for joining. So please do like, share and subscribe. Okay, they are watching recorded sessions. All right, no issues, fine. So lifespan of your RBC is 120 days, after which they are destroyed in the spleen. So spleen is known as the graveyard of RBCs. Yes? Okay, fine. So this is about your RBCs in a nutshell. So we were talking about RBCs. So RBCs are erythrocyte. So their shape is biconcave. They are circular, but they are enucleated. They do not have any cell organelles because they had to do the primary function, that is transport oxygen through hemoglobin, right? So the next one is abundant. They are the abundant of all the three types of cells compared to your WBCs and platelets. Your RBCs are much higher in account. So you have 5 million to 5.5 millions of RBC per millimeter cube of the blood. So RBCs are formed in the red bone marrow, and they have a pigment called as hemoglobin, and the level of that pigment is 12 to 16 grams per 100 ml of blood, and the lifespan of RBC is to 120 days, after which it is destroyed in the graveyard, that is the spleen, right? Yes, thank you so much, Antonio B. Fine. So moving further, now we are going to talk about leukocytes. So leukocytes are known as WBCs. They are colorless. So leuco means colorless, no color. So cytes are cells. So they are colorless cells, that is your WBC. So TLC is the total leukocyte count. So sometimes when you have a bacterial infection, so in your blood test you will have a TLC, that is the total leukocyte count. So they are nucleated, so they have a nucleus, and they are relatively lesser in number compared to the RBCs. So RBCs were in the range of millions. Your WBCs range around 6,000 to 8,000 millimeter cube. Yes, they lack hemoglobin. Yes, I completely agree. That is why they are colorless. Your leukocytes are short-lived. So they live for almost 13 to 20 days. So that is the lifespan. So leukocytosis, so this is a condition, leukocytosis, increase in the total leukocyte count. So TLC is this, total leukocyte count. So leukocytosis is the increase in the TLC. It occurs in case of bacterial and viral infection. Ma'am, why during bacterial or viral infection leukocytes increase? Because leukocytes play a very important role in the immune function. So whenever there is a foreign particle like bacteria, virus entering inside a body, so the body has to react against them, right? So that is why during a viral or a bacterial infection, the amount of leukocytes increases. Okay? Fine. So leukocytopenia, so this is opposite to leukocytosis. You have a decrease in the TLC. This is also a risky condition because when you have less amount of WBCs, then your body becomes susceptible to a lot of diseases because your body is not able to fight back, right? So that is also one of the reasons. The third one is leukemia. So leukemia is abnormal increase in your WBCs, so that leads to blood cancer. So blood cancer is also known as leukemia. Fine. So here are some terms. So WBC is leukocytes. They are colorless because they lack the red color iron containing pigment, that is hemoglobin. So TLC is total leukocyte count. So they are nucleated and relatively less in number, and the average is 6,000 to 8,000. So leukocytes are short-lived. They live for 13 to 20 days, that is their lifespan. So leukocytosis is the increase in the total leukocyte count that occurs during bacterial or viral infection. So leukocytopenia is the decrease in the total leukocyte count, and leukemia is the abnormal increase in the TLC, that is blood cancer. So you have types of leukocytes. Unlike your RBCs, your leukocytes are of two types. One is granulocytes, the other one is agranulocytes. Okay. So granulocytes, that is they contain granules. So agranulocytes, this is absence of granules. So granulocytes are divided into three. So you can remember this as Ben. So B stands for basophil, E stands for eosinophil, and N stands for neutrophil. So eosinophil is also known as acidophil. So you can call it as Ben or Ban, both are the same. So they come under granulocyte. Fine? Okay. So why are they called as neutrophils, acidophils and basophils? So basophils, they stain or they take up a basic dye. So these are called as acidophils or eosinophils because they take up or they stain with an acidic dye. They are called as neutrophils because they do not stain with either acidic nor basic dye. Okay, so that is the reason they are called so. But what is the function of a basophil? It produces inflammatory and allergic reactions. And eosinophil, it fights against parasitic infections. And neutrophil, they help in phagocytosis. Phagocytosis is cell killing. They capture a cell and they kill it, that is phagocytosis. So the function is very important. Then here we come to the agranulocytes, that is absence of granules. You have two of them, one is lymphocytes and monocytes. So lymphocytes produce immune response and your monocytes, they fight off bacteria, virus and fungi, right? So your lymphocytes are of three types, so you can say two major types. So you have B lymphocytes and T lymphocytes. So this is the entire classification of your white blood cells. Hello sweetie, so thank you so much for joining my lecture today. So I hope you're doing well. So please don't forget to like, share and subscribe. Okay, so here we talk about the types of blood cells. So granulocytes and agranulocytes, they are filled with granules, that is Ben, basophil, eosinophil and neutrophil. And this is lymphocyte and monocyte. Okay, so lymphocyte produces immune reaction and monocytes fights off bacteria and virus. So neutrophils, they play an important role in phagocytosis. So literally your neutrophils and monocytes are phagocytosis. They do phagocytosis. Your neutrophils and your monocytes. Fine? And they play a role against parasitic infection, but these produce inflammation and allergic reaction. Right? So this is the classification of your WBCs. So now talking about the abundant WBC. So WBC has two components. So among the 5 types, your neutrophils are the most abundant one. So neutrophils constitute 60 to 65% of the total WBCs. So basophils are the least. So when we say Ben, so this is the most abundant and this is the least one. So basophil is 0.5 to 1%, but your this is your basophil and your neutrophil is 60 to 65%, right? So neutrophils and monocytes are phagocytic, they destroy the foreign organism entering the body. So basophil, they secrete histamine, serotonin, heparin, which is involved in the inflammatory reaction. Ma'am, what is inflammatory reaction? So when an ant bites you, it becomes reddish and it becomes swollen, right? That is inflammatory reaction. Yes, sweetie, happy to see you after a small break. Yes, even I am excited to see all students back. So thank you for joining me. Fine. So eosinophils, they resist infection, they mostly fight allergic reaction. So these are the function. So finally, we are going to talk about platelets today. So what are platelets? So platelets also have another name. So just like WBCs are called as leucocytes and RBCs are called as erythrocytes. So platelets also have another name. So platelets are called as thrombocytes. Okay. So these thrombocytes, they come from a precursor cell that is known as megakaryocytes. So this is the cell which differentiates to form your platelets, right? So what is the function of your platelets? So platelets help in blood clotting. So whenever you have a cut or whenever you have a wound, so blood oozes out of your blood vessels, right? But it does not continue for hours and hours. It just stops within minutes because your blood clots. So blood clotting is done to prevent the loss of blood from your blood vessels. So how does the clot happens? So the injured tissue, let's say one portion of the tissue is injured. So the injured tissue releases what is known as thrombin. Okay, so ideally this thrombin is present in a precursor stage, that is so it is present in prothrombin stage. The injured tissue, the tissues have prothrombin. When it is injured, it gets activated to thrombin. So this is with the presence of an enzyme, that is thrombokinase. Fine. So now this thrombin activates your plasma protein, that is fibrinogen, into fibrin. So fibrinogen is an inactive form. So it is converted into fibrin. So this helps in clot. So this is how your clotting factors work. Fine. So is this clear how clotting factors work? So this is exactly your clotting factors work. So you have other 14 factors which you do not have to memorize. So that is not needed for NEET exam, but you should remember this much. Okay. So with this, the components of blood is done. So with this, we come to the end of the lecture. So I hope you remember whatever we studied. So we spoke about why is blood important, or why is circulatory system important. So we spoke about the classification of blood. So we spoke about the formed elements, and we spoke about the plasma. So under plasma, we concentrated about the plasma proteins. So plasma proteins include albumins, globulins and fibrinogens. So we spoke about the function of each of them, and this is the largest plasma protein. So formed elements include RBCs. So then it is WBCs and platelets. Right? So we spoke about platelets. So we spoke about RBCs and WBCs. So WBCs have many components, right? So WBCs are further divided into granulocytes, the one which has granules, and it is divided into agranulocytes. So granulocytes include your BEN, that is basophil, eosinophil and neutrophil, whereas your agranulocytes include lymphocytes and monocytes. So we spoke about the function of each of them, and finally we ended with the topic of platelets, where we spoke about the clotting machinery, right? So today we come to the end of this chapter. So blood and its components are done. So tomorrow we'll be talking about the blood grouping. So we have to talk about ABO blood grouping and RH blood grouping, and we also have to summarize what is erythroblastolysis fetalis. So I will meet you tomorrow at 5:15 p.m. so where we will talk about blood grouping. So until then, this is me wishing you more and more. So stay tuned, and I will meet you tomorrow. So until then, bye.